Good morning, students. Today I am going to explain about the rate law and rate constant. Okay, rate law and rate constant. It will be asked in 2 mark or 3 mark questions. Sir. It is very important topic. Please listen carefully. Okay, let's see. We have just learned that the rate of reaction, the rate is nothing but speed. Okay, the rate of reaction, the rate is nothing but speed. The rate of reaction depends upon the concentration of the reactant. Okay, now let us understand how the reaction rate is related to the concentration by considering the following general reaction. Okay, the rate of reaction can be depends upon the concentration of reactant which is involved in a reaction. Okay, this is called as a reactant react to give physical product. Okay, this is called as a reactant. The rate of reaction fully depends on this reactant. Okay, this is an example of reaction. XA plus YB equal gives a product. Okay, this is called as a reactant. Okay, the speed of this reaction it depends on this concentration of the reactant. Okay, let's see. The rate law for the above reaction is nothing but it is called as a rate law. Okay, the rate law for the above reaction, the rate law for XA plus YB gives product. Okay, the rate law for the reaction is nothing but rate equal to K, the concentration of M and the concentration of B to the concentration of N. Here M and N are the rate laws, order of reaction. M and N are called as the order of the reaction and K is nothing but proportionality constant. Okay, K is nothing but proportionality constant. Here M and N is nothing but the order of reaction. We can predict the order of reaction only by experiment. Okay, if you want to find the order of reaction means you should do some experiment. From that you will get the value of order of reaction, that is nothing but M and N. Okay, A and B are the reactant, K is nothing but proportionality constant, rate is nothing but speed of reaction, where K is the proportionality constant called as the rate constant. Okay, the values of M and N represent the reaction order, that is nothing but order of reaction order both are same. Okay, with respect to A and B respectively. The overall order of reaction, the overall order of reaction, if you want to know the overall order of reaction means you have to add the order of the each component, each reactant. Okay, here the order of reactant A is nothing but M and the order of reactant B is nothing but N. So if you want to know the overall order for the reaction, you should do the addition. Okay, M plus N is nothing but the overall order of reaction. The values of the exponents, that is nothing but M and N. The value of exponent, that is nothing but M and N in the rate law must be determined only by the experiment. Okay, they cannot be deduced from the stoichiometric of the reaction. Okay, for example, consider the isomerism. Isomerism means same molecule formula but positive different structure. Okay, cyclopropane. Do you know the structure of cyclopropane? This is called as a cyclopropane. Okay, this is called as a cyclopropane because here we have 3CH2 3CH2 and the structure should be in a cyclic in nature. Okay, let's see. The results shown in table 7.2 indicates that here very important line, if the concentration of the cyclopropane is reduced to half. Okay, if the concentration of the cyclopropane is nothing but reactant. Okay, if the concentration of the cyclopropane is reduced to half, the rate also reduced to half. Okay, if you reduce the concentration of the reactant to the half, the rate of that reaction also reduced to half of it. Okay, the rate also should be reduced to half. It means that the rate depends upon the concentration. Okay, that means cyclopropane is to the first power. Okay, rate equal to K, the concentration of cyclopropane, it is nothing but order of the reaction 1. Okay, if you want to find out the proportionality constant K, you should divide the rate by the concentration of the cyclopropane. Okay, this is the formula to find out the value of K or value of rate or value of a cyclopropane, that is concentration of cyclopropane. Okay, let's this is rate constant for some isomerism. Okay, this is first reaction and the second one and the third one. Okay, let's understand how to find the constant rate of reaction or order of reaction. Here by taking by taking these three reactions for various rate, we should find out the order of the reaction. Okay, let's see. Let us consider the another example for the oxidation of nitric oxide. Okay, oxidation of nitric oxide, this is called as a nitric oxide NO. Okay, oxidation means addition of oxygen. Okay, when the reaction occurs between the nitric oxide and oxygen, it will give the product of nitrogen dioxide. Okay, series of experiments are conducted by keeping the concentration of one of the reactant constant and changing the concentration of others. Okay, here we take the various concentration of the nitric oxide. Okay, we are taking the various type of nitric oxide concentration. Okay, by that if the concentration changes, the rate of reaction also changes. Okay, the rate of reaction also changes. This is nothing but a concentration of nitric oxide, concentration of oxygen. If the concentration of nitric oxide and oxygen 1.3 and 1.1, the rate of reaction will be 19.26. The concentration increases of the oxygen, the rate of reaction 38.40. If the concentration of nitric oxide will be 2.6, the rate of reaction is nothing but 76.80. Okay, here if you double the any one of the reactant, concentration of the reactant, the rate also doubled. Okay, if you double the rate of double the concentration of nitric oxide, the rate here, the rate also doubled. Okay, let's discuss. Okay, this I think but first reaction and second is the third one. Okay, rate equal to K, the concentration of nitric oxide to the M and concentration of oxygen to the N. Here M and N is nothing but order of reaction. In this calculation, we are going to find out the order of reaction, that is nothing but M and N. Okay. For experiment 1, the rate law is nothing but rate 1, because we have a 3 rates. Okay, so we have to put rate 1, rate 2 and rate 3. For rate 1 equal to K, the concentration of nitric oxide to the M and the concentration of oxygen to the N. Okay, here the rate value for the first reaction is nothing but 19.26 into 10 power of minus 2. Seeing this here, the 10 power of minus 2 is given in the top of the table, so we can take as a same 10 power of minus 2, here also 10 power of minus 2 and here also 10 power of minus 2. Okay, let's discuss. Yeah, rate is nothing but 19.26 in 10 power of minus 2 equal to K. The concentration of nitric oxide in the first reaction is nothing but 1.3 is given here to the power M, and the concentration of oxygen in first reaction is nothing but 1 to the power N. And similarly for experiment 2, we are putting like the same as above. Rate 2 is nothing but rate 2 equal to K, the concentration of nitric oxide and the concentration of oxygen. We have to put the values of concentration of nitric oxide and oxygen like this. We have to take this equation as a second 2, and for rate 3 equal to K, the concentration of nitric oxide M and the concentration of oxygen is to the power N. The rate of the third reaction is nothing but 3.46. Okay, 3.46 here, 3.46. The rate of third reaction is 3.46, 76.80. Okay, 76.8 into 10 power of minus 2 equal to K. Concentration of nitric oxide but 2.6 to the power M and 1.1 to the power M. Okay, so if you want to find the order of the reaction for the oxidation of nitric oxide, we have to divide the following equation, that is nothing but equation 1, 2 and 3. Okay, first we have to divide the equation 2 and 1, so we will get, we have to cancel 10 power minus 2. If you cancel this, you will get the answer of 2. Okay, you will get the answer of 2 equal to here k to the power of k, the concentration of 1.3 the rule m, and the concentration of 8. You have to cancel this, you have to cancel k, and if you divide this you will get the answer of 1. Okay, you will get the answer of 1, that is you will get the answer of 2. Okay, you will get the answer of 2, that is nothing but 2.2 divided by 1.1 is nothing but answer is nothing but 2. Okay, here if you divide this 2 by 1 you will get answer of 2 equal to 2.2 divided by 1.1 the whole power n, because we have same power, same order of reaction n. Okay, if you divide 2.2 by 1.1 you will get answer of 2. Okay, 2 to the power n. And if you want to know the value of n, we have to what makes the here if you here the 2 equal to 2 power n. Okay, if you want to apply the value of n by squaring the by multiplying the power to this 2 you will get the same value as a 2. Okay, 2 equal to what makes the power to make as a 2. Okay, if you want to put the value of n equal to 1 is nothing but the 2 into 1 is nothing but 2 power 1 is nothing but answer is also 2. Okay, here 2 equal to 2, so here the value of n is nothing but 1. Okay, here you will get the value of order of reaction n. Okay, now we are going to find out the order of reaction m. Okay, for that we have to multiply the equation 3 by 1, so you will get like this. Okay, therefore the order of reaction is first order with respect to oxygen. Okay, equation 3 and equation 1. Okay, equal to 76.8 into 10 power of minus 2 divided by 19.26 into 10 power of minus 2. You will get cancelled. Okay, equal to k concentration of 2.6 to the power m and the concentration of 1.1 to the power n divided by concentration of 1.3 to the power m and the concentration of 1.1 to the power n will get cancelled, and if you cancel this you will get the value 2. Okay, and if you cancel this you will get the answer of value 4. Okay, so the 4 is it as we discussed earlier. Here if you cancel this you will get the answer is nothing but 2. Okay, let's see. Okay, 4 equal to here only we have this k to the concentration of 2.6 to the power m and the concentration of 1.3 to the power m. Okay, if you put this value 4 equal to 2.6 divided by 1.3, if you divide this you will get answer of 2 power m. Okay, equal to 4. So 4 equal to 2 power m. Okay, what makes 2 to become a 4? If you apply the value of m equal to 2, the 2 square is nothing but 4, so we will get the equal 4 equal to 4. Here the value of m is nothing but 2. Okay, here the value of m is nothing but 2. Therefore the reaction is second order with respect to n. Okay, if you get the order of reaction 1, the reaction is considered as a first order reaction. If you get the order of reaction value 2, the reaction is considered as a second order reaction. Okay, first order reaction is second order reaction. It will be confirmed by seeing the value of order of reaction. Okay, therefore the reaction is second order with respect to NO, nitric oxide. The rate law is rate 1. The rate law is nothing but for first reaction is nothing but k, the concentration of NO to the power 2 and the concentration of oxygen to the power 1. This 2 and 1 is nothing but the order of reaction. Then if you want to find the overall order, we should add the 2 plus 1, so we will get the 3. The 3 is nothing but the overall order of the reaction. Okay, let's discuss the difference between the rate constant and the rate of reaction. Okay, difference between rate and the rate of the reaction. Okay, it will be asking a 3-mark question answer. Very important, please make a note. It will be asking a 2-mark or 3-mark question answer. Okay, rate of reaction is nothing but speed of reaction. I am saying often it represents the speed at which the reactants are converted into products at any instant. Okay, it represents the speed at which the reactants is converted into products at any instant. Rate of reaction, it is proportionality constant, that is nothing but rate constant of reaction K. Okay, and the second point is thing but it is measured as decrease in the concentration of the reactant or increase in the concentration of the product. Okay, it will be measured if the concentration of the reactant decreases or the concentration of the product will be increases. If the reactant concentration decreases, at the same time the product concentration will be increases. Okay, and the rate constant of reaction, it is equal to the rate of reaction when the concentration of each of the reactants is unity. Okay, next, it depends on the initial concentration of the reactant. Initial means starting concentration of the reactant. Okay, it depends on it. It does not depends on the initial concentration of the reactant. Okay, these three difference you should write for the difference between rate and rate constant of the reaction. Okay, next is the molecularity. It will be asking a 2-mark or 3-mark question. Molecularity. Kinetic studies involve not only the measurement of the rate of reaction but also proposal of the reasonable reaction mechanism. Each and every single step. This is the answer for elementary reaction. Okay, elementary reaction. What is elementary reaction? Each and every single step in a reaction mechanism is called as elementary reaction. Each and every step. If you are writing the simple reaction means it contains more number of steps. How the reactant will be converted as a product. Okay, if the reactant converted as a product means in that you will get the more than 2 or 3 steps. That is the reactant converted as a product. Okay, let's see. An elementary step is characterized by its molecularity. The total number of reactant species that are involved in an elementary step is called as molecularity of the particular step. Let us recall the hydrolysis of a tertiary butyl bromide. Tertiary butyl bromide studied in 11th standard. Okay, since the rate determining elementary step involves only tertiary butyl bromide, the reaction is called as unimolecular nucleophilic substitution or SN1 reaction. Okay, by seeing the SN1 reaction, nucleophilic substitution reaction 1, you will get the molecularity. Okay, let us understand the elementary reaction by considering the another reaction. Okay, by using this reaction we can understand the elementary reaction. Okay, the decomposition of hydrogen peroxide. Decomposition is nothing but breaking. Okay, decomposition of hydrogen peroxide. Hydrogen peroxide is nothing but H2O2 is nothing but hydrogen peroxide. Okay, if decomposition of hydrogen peroxide takes place, it will be converted as a water molecule and oxygen. This will be the decomposition product of hydrogen peroxide. Okay, it is experimentally found that the reaction is first order with respect to both H2O2 and I2. I minus. Here in this reaction, I minus is act as a catalyst. I minus is act as a catalyst. Okay, this is called as reaction A plus B in presence of catalyst gives AB. Okay, here the catalyst is nothing but C. This is called as the overall reaction, and the steps for this overall reaction is nothing but A plus, here C is nothing but catalyst AC. Okay, and then AC plus B equal gives A plus C gives a AC. Okay, here C is nothing but catalyst. This is step 1, and for step 2 is nothing but AC plus B gives AB plus C. As we will again get the C. Okay, we will get again the C. Here this is nothing but the steps of this overall reaction. Okay, let's see. Here is 2O2 and I minus, which indicates that I minus is also involved in this reaction. I is nothing but catalyst, and this catalyst also involved in a chemical reaction. Okay, catalyst. The mechanism involved the following step. This is the decomposition reaction of H2O2. It will be explained by step. Okay, in step 1, the reaction occurs between the H2O2 and the catalyst. You will get the answer of H2O, product of H2 and OI. Okay, and the step 2, again H2O2 react with this OI to get the product of H2O2, I minus and O2. And for this step 1 reaction, the overall reaction is nothing but 2H2O2 gives 2H2O plus O. Okay, if you add these two reactions, we will get, here the I minus will be cancelled. Okay, this OI and this OI will be cancelled. Okay, we have 2H2 here 1H2 here, so we will get the answer of 2H2O2 gives, we have 2H2O and we have 1 O2 gas. Okay, this is called as the overall reaction. It will be get by adding the step 1 and step 2 reaction. Okay, these two reactions are elementary reaction. Adding equation 1 and 2 gives the overall reaction. This is called as the overall reaction. Okay, step 1 is a rate determining step. Here the step 1 is a rate determining step since it involves both H2O2 and I minus. The overall reaction is nothing but bimolecular reaction. There is nothing but SN2 reaction. Okay, SN1 reaction. Difference between order and molecularity we will see in the next class. Okay, thank you.